This video illustrates a class diagram using Mac A&D. We'll start by opening a pre-built project that includes a data dictionary document, a sequence diagram, and the class diagram, which is where we're going to focus most of our time here. A class diagram consists of boxes representing object classes in the object-oriented system. Each box has the name of the class, a list of its attributes, and a list of its operations. There's also relationships between those boxes represented with named arrows. For example, here we can see that the TEventHandler class inherits from TObject. Likewise, TDocument, TWindow, TPalette, and TApplication also inherit from the TEventHandler class. There's other kinds of relationships on the diagrams as well. For example, here's an aggregation relationship where the TList class aggregates a collection of T-shaped classes. Class objects are added to the diagram with the class tool. When you click on the diagram, a properties dialog is presented where you can name the class. You can also bring up the properties dialog by selecting the class object and clicking on the properties button, and the properties dialog is presented. You'll see that there is a name field for the properties dialog, which defines the entry name in the data dictionary, and an associated displayed as field, which by default will be the same name. That's the name that's actually presented on the diagram itself. If we select other types of objects on the diagram, such as the connection object, we see that there's also a properties dialog that defines the characteristics of that particular connection. In this case, we have a inheritance relationship between the TEventHandler and the TObject class, and so we can see the type of relationship shown within the connection properties dialog. After drawing a class diagram, you can click the merge button to create dictionary entries for each class object drawn on the diagram. Once you have those associated dictionaries generated within the data dictionary, you can then select any individual class and define the detailed information, which is where the attributes and the operations of that class are defined. For example, we've selected the TEvent class. We'll bring up the details dialog for that particular object class, and we have some general information where we can give a description to the class. We have an attributes panel where we can define each individual attribute, an operations panel where we can define the individual operations of the class. If we look at an attribute, for example, and double click on the name of an attribute, we can define detailed information like its access and other information about that particular attribute. Maybe its data type. Likewise, we can do the same thing for an operation. If we select the operations panel, we can either add new operations by typing the name here and clicking the add button, or edit the specific details of a particular operation. For example, this particular operation, the setup menus, we'll double click that. In that operation we can define its data type, its access, and other specific details of that particular operation. After drawing objects on the diagram, merging it into the dictionary, and then adding detailed information about each of those objects, we've built up a collection of detailed information in our data dictionary. If we take a look at that data dictionary, we can see it's a set of entry names. Some of those entry names are color-coded. For example, if we look at the default color scheme, we can see that all classes are red, attributes are blue, and operations are green, based on the color defaults we've assigned. We can also look at the structure of the data dictionary using the format menu. We can look at it as a tree structure where we can show and hide the details of a specific set of entries associated with an object class. For example, we can see that a T-box class has a couple of attributes and a set of 4 operations associated with that class that's defined on the diagram. Essentially, the the data dictionary becomes the detailed repository of information about each class and each of its members, including the details of those members like data types, parameter lists, descriptive information. Once we've defined the classes and detailed information like the attributes, operations, data types of those attributes, and parameter lists of the operations, we might want to generate some source code. We can select an object class, click the code button, and generate the starting point of that source code. Here we have a declaration of the TObject class with the public and private attributes and operations generated, as well as empty function frame for each of the operations. This is generated into a code file and is presented within a browsing window. The code that actually gets generated depends on a number of factors. For example, based on the language you've selected, you'll be generating source code for different languages. You can also generate code for a specific selected class, or you could generate code for all the object classes on the diagram at once to a single file. For example, if we used the generate batch code command, we would be generating a set of source code for a whole batch of classes. We could also customize the code prior to generation using the customize dialog, where we can change the style of code that gets generated and other characteristics about that generated code.